Hello, everyone. My name is Ievgen. I'm from the European Broadcasting Union. That is the union of public service media broadcasters and some private companies as well. It's called European, but it's actually, we have members around the world, including some members in Canada, in North America, in Australia, in Africa. I'm going to be talking a little bit about the effort that we created and led in the media over IP industry. It's the JTNM Tested event. We're going to be talking a little bit about what it is, why did we do that, what is JTNM anyway, what documents we produced, how we were testing, why we were testing those things, what are the findings and results, a little bit about the outcome and the conclusions. Anyway, the JTNM stands for Joint Task Force on Network Media. This is the organization that was created by AMWA, EBU, the SEMT, and the VSF in order to promote open standards for media over IP, including some advocacy and some community building as well. So we started this program first in March of 2019. So the first iteration of the program was for the NAB. It was this NAB anyway in March. And the second iteration that happened just now in August of 2019 was for the IBC. We kind of have it linked to the trade shows because of the marketing efforts around it. But what you need to understand is JTNM Tested is not a certification program. We are not the certification body to issue like a compliance statement that this particular product is compliant. The JTNM Tested is a snapshot in time. So we actually recorded the software and the hardware versions of the devices that we tested. And we say that in this given environment, for this particular software and hardware, this device performs like this. And there is an open report that you can go and download. There will be a link to that report flashing on multiple sites. And I encourage you, of course, to go and scan your badge, to get the slides, to get the handouts, and to go on their website and download not one, not even two, but 3 reports for the previous program, and for this one. For this one, it's going to be 2, and I'll talk a little bit about that. And get the results, get familiar with how we did that and what was actually done. So those are the documents that you'll get, the test procedures, all the test equipment is listed there, all the results there on the so-called catalogs. And this time we actually expanded the test plan and the catalog to include the control plane, because a data plane is nothing more than just moving media from point A to point B, and the fun part starts when you actually tell the devices to do things, tell the devices to initiate that data stream, or tell the device to get the data from point A to point B and do something with that data in point B. So anyway, we had 3 types of tests this time for the second iteration of the program. The basic SMT 2110 behavior, so the actual data plane, and the control plane, which included the AMWA NMOS specifications and the JTNM Technical Recommendation 1001-1 for the even more broader picture. Also this time, we did the cybersecurity vulnerability assessment, because cybersecurity is extremely important in this kind of environment, because we're moving more and more towards traditional IT and IP technologies, and of course adopting best practices not only for the management of the infrastructure but also securing the infrastructure is extremely important. So we had 32 different vendors who attended the facility of the headquarters of Riedel Communications in Wuppertal, Germany. Thank you very much, Riedel, for hosting us. 71 different products in total were tested for the data plane basics. So for the first test, which is the basic 2110 behavior, and also 34 out of those products were tested against the control plane tests. You may be familiar with this one, so I'll quickly jump through that without going into too much details. If you want to know more about what it is, this is EBU publication called EBU Tech 3371, and this is called the minimum user requirements to build and manage IP-based media facility. And in For short, it's known as the EBU Pyramid for media nodes. So the EBU Pyramid explains the user requirements towards the industry in terms of what we as users would like to see implemented on every layer of a stack of media communication. So we have a media transport, time and synchronization, discovery registration, configuration monitoring, and the security, of course. So if we map it a little bit towards our GTNM tested initiative, the first test plan and the first round of testing, which was the basic data plane, covered at the top of the pyramid, which is widely adopted, widely accessible. But we had to move forward. We had to push the industry a little bit more, and we included the discovery and registration configuration management, so all the control planes testing in this by doing the ANMOS/TR1001 test plan. And of course, infrastructure that is not secure is not a good infrastructure. So security testing as a base layer of everything also was introduced for the second round of testing. So the documents, the supporting documents that we produced for all of this were of course the test plans, so the SMT-ST2110 test plan, the ANMOS/TR1001 test plan, and for cybersecurity we didn't have an official test plan, but we had already the publication made by EBU, which is EBU R148, stands for Recommendation 148, which is pretty much a test plan on how you would assess, would you make a cybersecurity vulnerability assessment at home for your own device. So it's like a questionnaire. Can you do this? Are you doing this? Why are you doing this? Why you should not or should be doing this? And of course, if we do that again, if the initiative ever repeats, we will produce a full-blown test plan for the cybersecurity assessment as well. So the test plans are actually the extremely detailed explanations of what tests we did, how we did them, why we did them, what were the criteria of pass or no pass for a particular test. They're very well structured, and we'll talk about the structure of the document a little bit more. We also did some pre-testing documents. So the pre-testing concept was something that we introduced this time because we said, okay, for all vendors, for all equipment pieces that you will be submitting for the testing, it is absolutely essential and mandatory for you to take the test plan and run it against your piece of equipment in advance in your lab and provide us with the results. It was extremely important and beneficial. It was recognized by the vendors in our post-event survey. But in order to help them do that, we produced a bunch of supporting documents, which are the capturing guide, how to make a valid stream capture at home, should you or should you not have adequate equipment for that. How to use our main tools. So the main tools of the testing were the EBU list. It stands for Live IP Software Toolkit. It's an open source project that is designed for measuring and troubleshooting the 2110 environments, including some audio measuring and including also some ancillary data testing. And also the official ANMOS testing tool provided by AMWA. So very briefly, the 2110 test plan covered, of course, the vast majority of 2110 suite of standards. Of course, it's not a one document, it's a bunch of documents. The 2059 document, which is the base PTP profile for that, and of course the 2022-7, which is the multi-port redundancy. So 2022-7 was pretty aggressive test. We're going to talk a little bit about the results, but we basically had an impairment generator introduced in the network, and we were hitting 25% of packets from both legs sequentially, and we were expecting the device to recover from that. And of course, this time we expanded the program to test a little bit of UHD. So all the tests were run twice if a device was supporting UHD, once for HD and one for UHD. In a control plane, so ANMOS/TR1001 test plan, we introduced testing of DHCP and LLDP, which are absolutely essential for any infrastructure orchestration. So if you're using any automated tools that build your representation of your infrastructure in the form of a diagram, if it's an automated tool, it relies on LLDP, Link Local Discovery Protocol, and of course it's an important part of TR1001-1. TR1001 system resources that will become the ANMOS specification ISO 9, of course ISO 4.5, discovery and registration and connection management, and ISO8, the audio channel mapping. This all was part of the NMOS/TM1001 testing, because that's all what is important building pieces for properly managed infrastructures. So let's talk a little bit about findings and results and what you need to understand. And by the way, this is the link to the, that's once again the appearance of a link for the test catalogs for you to download. What you need to understand is this talk is usually held by 3 people. It's my colleague Willem Vermoost and our colleague from BBC R&D, Andrew Bonney, who were actually in charge of the testing, and they were compiling the final results, because statistics, this is not something I enjoy doing, but let's bear with me and let's hope that I can enlighten you about the results. So when, not if, but when you go on this link and download not 1, but 2 and 3, don't delay download today, the test catalogs, you'll get something like this. So on the left here, you cannot really see it in this screenshot, but on the left you'll have a list of equipment that was tested, including the versions of software and hardware revisions for that particular device. And on the top, you'll have the list of tests and the numbering of the tests. So for example, there is test 2.1.2, which is log to PTP test. You can take that number, go back into the test plan and read about test 2.1.2 in greater detail, how the test was done, what were the configuration for the tests, what was the criteria, and then in the actual spreadsheet, you will have a color coding. It's either green, either white, or gray. And green stands for the test has passed, everything is good, everything is according to the standard. White means not applicable, the test is not applicable, so the device by design cannot do that. And you will have, of course, chunks of white space through the spreadsheet, for example, for video tests that are not applicable for audio devices, obviously. And gray would mean a device has not passed the test, or the test was not attempted for various reasons. Maybe a vendor decided not to test that because they were not sure. Anyway, a little bit of statistics. So 100% pass rate, 31 out of 71 devices, which is already a pretty good results considering the aggressiveness of tests. All but 22 devices achieved more than 90% pass rate across the board, so that's even better. The worst results, unfortunately, were in the 2 fields that are important, which is the multiport redundancy, so 2022-7. Again, this was a very aggressive test, and also in our assumption, the KPI should be 0 failures for this particular test. It's the 2110-21 tests that are critical in order to have the interoperable and scalable solutions, and also the SDP delivery, because SDP is also an important part for orchestration and connection management in your facility. So those have to be 0, like really. But we had some failures in there, which is unfortunate, but it's not life-threatening, but there is still room for improvement. So a little bit of recap. Common issues, of course, as I said, the 2022-7 gave people some hard times. Disturbing file rate in -21 and -10. A lot of products were still struggling with correct RTP timestamping. This can be linked to some ambiguous language in the standards. We will be following up with SMPTE about that, but this is something that can be improved. Again, it's not deal breakers most of the times, but just something to clear out. And unfortunately, there was still not a lot of UHD cable products at least submitted for testing. And overall, of course, the success rate is much, much better than the previous time. So those numbers that I talked about can be seen as like gloomy and it's not working. No. It's very good. It's actually much better than the previous years and the previous Plugfests. We see clear improvements and the industry is moving forward. Open standards are adopted. It's very good. And vendors recognize the need and the value of the pre-testing, because a lot of vendors actually came to us afterwards, said, well, we didn't understand why we had to do this mandatory at-home pre-testing, and then we did it, and then realized that our stuff is broken, and we were able to fix it before the official testing, which is good, so thank you. Like, okay, that's cool. That was the plan. PTP stability, something that is extremely important. A media network is as good as your PTP, and of course, unstable PTP will lead to unclear results of the testing and also unclear behavior of the equipment. And this time, the PTP stability was excellent, and we didn't have any outages. So we can happily conclude that yes, it works. Yes, it's all very good. Pod testing can be optimized. The way we organize the testing is that we had a global layer 2, so-called a zoo network, and for the actual testing, we moved the device for a certain period of time into a separate VLAN and a separate subnet to include some kind of cross-talking and to have as sterile environment for testing as possible. This is a very time-consuming mechanism, so I will be talking a little bit about that later today on my network automation talk, and I'll explain why it's challenging. And this is something that we can still improve in terms of testing. So this internal discussion going on how we should be doing this. And it is, of course, a last bullet point, extremely critical to feedback the results into the standardization bodies in order to make some error corrections, ambiguities, resolutions. Overall, the standards is very solid, it works, so there is absolutely no risk in a decision. Should I go IP or should I not go IP? You should. You just need to be cautious of what you're doing and how you do that. So a little bit of results for Animos on TR1001. Again, don't delay, download today. 100% pass rate, 6 out of 34 devices for the overall global testing. I'm not going to comment on that. It's not a lot, but for those devices that did that, it was very good. We're going to talk a little bit about that. So 100% pass rate, 20 out of 34 for Animos ISO4 and ISO5. So ISO4 and ISO5 are two fundamental specifications in order to build orchestratable and controllable facility, because those are discovery, of course, discovery and restoration, and connection management. You cannot really build a facility without those two. And of course, those are the open alternatives to some proprietary things that some vendors are doing. And all but 4 devices achieved more than 100% pass rate, so that's very good. And the reason that 100% pass rate was so low is because, unfortunately, LLDP support for the devices was not so good. You can argue that LLDP is a very particular one, but again, think about moving more and more into traditional IT and IP best practices. LLDP is fundamental for that. You'll have to adopt it at some point. And surprisingly, DHCP support was better, but still some devices struggled to do DHCP, which is unfortunate. Overall, almost 8,000 individual tests were carried out. Most of them were automated. So it is important to understand that the Animos test suite, as well as EBU Live IP Software Toolkit, are automated tools. So you even don't have to do any manual labor. You just throw a device to those control suites, and you get the reports. Okay, so this one is a very interesting one. Very few common failures across devices beyond items which simply hadn't been implemented. Which means, if the feature was implemented, most of the times it was working fine. It was either implemented and was working, or it wasn't implemented at all. Some issues, some interesting issues were with ISO4 UID consistency. UID consistency means when the device boots, it has a unique identifier, then it goes into the registry and registers itself, and then the registry knows that that device with that UID identifier is this camera, for example. Then suddenly your camera power cycles, and it, for some reason, when it boots, it receives a different UID, so it generates itself a new identifier. It goes into the registry, and the registry, instead of giving all the sets and all the configuration that was attached to that camera, the registry would think, oh, that's a new camera, let me configure it as a completely new device. So in case of power outage, for example, you'll have a good time configuring your devices from the beginning, which is not something you want to do. We observed DHCP configuration confusion across nodes with multiple network interfaces. Yes, some of the devices were not sure how they should be managing DHCP, if the DHCP was running on both management and the media interface, including some dual port redundancy devices with 2 ports. They were confused. Sometimes they were running only one network stack against like a teeny tiny switch, with the multi-ports. So that's something that can be improved. In any case, stream and discovery testing, slow but valuable. Yes, some of the testing was manual. Some tests included manual reconfiguration of the device, but they were valuable, and they of course were important. And of course, the Animos test suite will evolve, and there will be more and more automation, including that. And pre-testing, again, for the control plane made a difference because people ran their devices against the automated test suite. They got the report, and they were able to fix some errors before even coming to the face-to-face event. And what is even more important, fully featured implementations were quick to test. If a device had support for DHCP, for LLDP, and then ISO4 and ISO5, it was literally one click of a button, everything was tested. No manual configuration. And this is where people said, oh, this makes a difference. Moving forward, the cybersecurity vulnerability assessment. In general, in total, 387 vulnerabilities found. Some of them were critical, and we had appropriate follow-up with those vendors saying, look, your stuff is broken, this is really critical, you have to fix it like soon. And of course there was some constructive dialogues with vendors, which is very cool, because for all the issues that we were discussing, the dialogue was always very constructive, it was very positive overall. 80% of the vulnerabilities are moderate, they can be exploited. Some arguments that we heard, like, okay, but this should be on a closed network, this is not meant to be like on a public internet, which is valid, but at the same time we're moving more and more into a converged networks, and you never know when a piece of lab equipment ends up in the production network, and at some point, maybe by the configuration mistake, that network may be exposed to the internet and stuff can happen, okay? You never know. So more info in the report. This is relevant for all of those results that I just spoke about, because all of them have dedicated talks that were done at the IBC IP Showcase, and I encourage you to go on the VSF YouTube channel and look for those. You will hear it from the people who actually did that, and they are way smarter than me, including the vulnerability assessment. Our good friend Gerben goes and breaks down all the different criteria and all the different vulnerabilities, how they assess them, how they classify them, which is even more important. Anyway, after the event, we ran a survey, and of course you'll have the handouts and you can read about them. Overall, the response from the vendors was mostly positive, in an average 4.5 for the questions like, should we do that again? Do you recognize the value of this? Was it beneficial for you? If we do that again, would you participate? So overall, it was pretty positive, and we're still in conversation with the industry for a question of should we or should we not repeat the program again. If we do, some potential future tests may include 2110-31 and -22, which are important because -31 allows you for a bit accurate AS3 transport, including some non-PCM audio formats. And -22 is of course a big deal because it introduces the mezzanine compression into the 2110 formats. Of course, in the control plane, the next logical step would be the testing of the registries and control mechanisms, because what you need to understand is that for all the testing, including the control and including the basic media transport, we only were testing the end devices. So we were not testing the network. It was given that the network is operational. We had a vendor, and the network was not tested. So you will not see around like the switch that is certified or it's like 2110 tested. No, it doesn't work like that. Of course, also we were not testing the PTP infrastructure. It was given that the PTP infrastructure is working. So we're testing only the endpoints and including the control plane. So only those devices that were providing APIs. So the devices that were consuming APIs like control panels or the registries were not tested this time, but we will see if it's possible to include those kind of mechanisms and those kind of implementations in the testing for the future. More serious PTP testing has to be considered. This also correlates with what I said. It was given that the PTP was working and we were not really stress testing any PTP. Maybe it's a good idea to do that. Well, we'll see. The pod approach can be deprecated in favor of fully routed networks. So of course now the network was layer 2. We see more and more tendencies on the architectural design that the network is fully routed, so every single switch port is not a switch port, it's actually a routed port, so the network is full layer 3, and therefore there will be no need for moving the devices into separate subnets and separate VLANs because then they will be isolated by design. And of course, general conclusions. Improved results compared to the first tested events. Yes, absolutely yes. The industry recognized the importance of the testing and they improved, and the testing program continues to push the industry forward in terms of adoption and clarification of the standards. The mandatory self-testing is essential. Yes, yes, absolutely, because some errors and some bad implementation was sort of fixed in advance. Of course, for some vendors, the event was a QA, and they were fixing their implementations on site. But for the most, they were completely ready for the testing. They arrived, and it was like boom, and we're up and operational. This event, it says needs, but may need to be repeated. We will see. We're in discussion with the industry, as I said, to get better quality implementations. Of course, it's the same drive forward, and to get more of the needed features of the pyramid. Because as we map those test plans to the pyramid, we will see that still some blank spots are there, and we will need to cover them. And of course, the value created by the event. We're getting current state of the implementations for you, the end user, so you can download the catalog and look for your particular device of choice and see how it performed, improving the implementation so it goes both ways. Both the users have the idea, but also the vendors have the idea of where they can still improve their implementations, and most importantly, safeguarding the investments for the new facilities, so you know exactly what to expect from the device when you consider it for a purchase. Anyway. Thank you very much for your time, and again, go and download those reports, those catalogs, and thank you very much for your time. Enjoy the show.